Hi guys, today we're going to talk about chemical bonds, specifically ionic and covalent bonds. Metallic bonds are more high school, like advanced high school and college level chemistries, but we're going to look at these two. We're going to split it into two videos. So the first one is ionic bonds, and the second one will be the covalents. That'll be really short. So our first vocab word for the day is chemical bonding, or bonds. This is the glue. It's usually an electrostatic glue, so positive and negative. Glue that holds an atoms together. Sometimes the atoms are really easy to break apart, and so their glue between them is really strong. And then other times it's a weaker bond, which means I don't need some kind of energy exchange to cause those bonds to break. So let's look at what makes an ionic bond an ionic bond. Get it all in frame. So first things first, defining an ionic bond. This is our little dachshund pen. Miss Fletcher got me this. An ionic bond is one that connects metals and nonmetals on our periodic table. So if you look at the really sketchy periodic table that I drew here, don't make fun of my picture, Hannah or Joe. The metals are to the left of the metalloid stair-step, and then the nonmetals are to the right. So for this ionic bonding, it has to be a metal and a nonmetal. So magnesium iodide, silver chloride, and magnesium oxide. These are all examples of an ionic bond because it is a metal and a nonmetal. If it happens to be two metals or two nonmetals, it is no longer classified as an ionic bond. It would be classified, if it's two metals, as a metallic bond, and if it's two nonmetals, usually it's a covalent bond. So our essential question for the day, our thing that we're going to try to answer before we leave this video chat, is what is it that holds these elements together? Why do they stay together and not just fly apart? So first things first, you need to locate your periodic table. You can either pull one up on a second window in your browser if you're watching this on the internet. You can get your paper one out of your small folder, or you can look on the wall if you're watching this in my classroom. So first things first, we're going to look at a very simple one, and that would be sodium and chlorine. Now when we put these two together, sodium chloride is a really fancy way of saying table salt. So we know that these things together are really simplistic. The boys are crying at the guinea pig. But we're going to look at how do these things bond together and what makes them stay together. So the first thing is we're going to start with two separate atoms. So we have a metal and a nonmetal. And then by looking at these two, so I have a metal and a nonmetal. How do I get them to connect to each other? If I've got two that are the same charge, they're not going to connect. So I have a positive and a negative, or I mean a positive and a positive. They're going to actually end up repelling each other. So how do I get these two to stick? So I have to give away one of my electrons. So usually it's going to be the one with the smaller valence electron number, which in this case will be sodium. It has one valence electron. So it's going to give its valence electron off to chlorine. Then our third step, moving stuff up. Our third step is going to be that the atoms get a different charge, and they're now going to be a positive overall and a negative overall. So what do we call these things? I mean, if you remember from our last video, these are our ions. So we've got sodium here with an overall positive charge now, and chlorine with an overall negative charge. And when I have a positive and a negative, let's scoot some of this stuff up. When I have a positive and a negative charge, what do you think they're going to do together? Well, hopefully you understand that ions with opposite charges are going to stick together. So we're going to get this nice cute little sodium chloride. Now you may have asked, how come, Miss Carter, Smarty Pants Carter that you are, how come up here I said chlorine? This is chlorine. But in the name it says chloride. Well, that has to do with the fact that here it is a neutral charge chlorine atom. But when we go through all of our steps, and I end up with a negatively charged chlorine atom, when it's got a net charge of 0, it's classified as chlorine. Get into focus there. When it's got a negative charge, it's classified as chloride. These names are just so that the chemist can understand when they're mixing that if it's chlorine, it's a neutral charge. If it's chloride, it's a negative charge. Sodium, because it now is positive, it remains in its full normal name. They only get a different name if they end up becoming with their negatively charged ions. So now let's look at what does all this have to do and how does this happen at a electron level. Now, because we don't have an electron microscope, we're going to do this with super cute pictures. I know you can't wait to see them. So we're going to stay with sodium chloride because it's pretty simple. So we start with our regulars. I have sodium with 1 valence electron and chlorine with 7 valence electrons. Well, every atom wants to have a full valence shell. So this means that chlorine, oh my goodness, where's my stuff? Chlorine, having 17 protons and 17 electrons, and sodium having 11 protons and 11 electrons, they can help each other out in getting this full valence shell. So if this random little 1 valence electron leaves the sodium and comes over to chlorine. Now chlorine has a full octet. Its outer shell is completely full and it's completely happy as an electron can be and as an atom can be. So now it looks something like this. It's full. The sodium, you may ask yourself, well, what happens to this ring, this outer shell now? Well, sodium no longer has 3 valence shells, or 3 electron shells. Now it only has 2, and it also has a full valence shell, because it can no longer support any others, and it doesn't have any extras on the outside. So that leaves us with chlorine, again, with a negative charge, with 18 electrons. So that's where I get my, because my electrons are larger, I get an overall charge of negativity. And because it's only by 1, I have an understood 1 there. And then on the other side, my sodium has 10 electrons, so it has an overall charge of positivity. So both of these now are an ion. So that's part of how we get the term ionic bonding, because they have created different ions as they've bonded. So hopefully that helps a little bit. We're going to look at covalent bonds here in a second, so click the next video and it should take you to that.